So here we have example 23 where it says, take for example a partition where k is equal to, say, employed and unemployed people. We know 10 of 15 are employed. 10 of 15 are employed. We are given information that some of these people are members of a film club. 4 of those employed and 2 of those are unemployed members of the club. Suppose we want to find out what the chance is that if we randomly selected one person out of 15, what is the chance that the person is a member of the film club? This is to find probability of F. So we have the probability of F. Now we have to see that the probability of F is equal to the probability of F and E plus the probability of F and E complement, which is given. Now we can see that it is equal to, we can separate this by independence. So we have probability of E times the probability of F given E plus the probability of E complement times the probability of F given E complement. Now we can draw like a diagram, a little graph on the right side, where the top half is E is equal to 10 because 10 out of 15 are employed. So E complement, which is unemployed, is 5. 5 are unemployed. And in the middle, we have F and E is equal to 4. Those are part of the people in the film club. And the 2 are unemployed. So in total, there's 6 people in the film club. So based off this diagram, we can fill out our rest of the equation. So probability of E is 10 over 15 times the probability of F given E, which is 4 over 10, plus 5 over 15 times 2 over 5. Now we can see that we can cross multiply, the 10s cross out, and the 5s cross out, leaving us with just 4 over 15 plus 2 over 15 is equal to 6 over 15, which is equal to 2/5, which is equal to 0.40. Yep, it is equal to 0.40. There we go. Now we can move on to example 25, where it says in a certain assembly plant, 3 machines B1, B2, and B3 make 30, 45, and 25% respectively of the products. It is known from past experience that 2, 3, and 2% of the products made by each machine respectively are defective. Now suppose that a finished product is randomly selected. Now there's 2 parts to this. Or part A is asking for what is the probability that is defective, and B is asking if a product was chosen randomly and found to be defective, what is the probability that it is made by machine B3? So we're going to move on to the next slide on this one. So now with this problem, we can start with our tree diagram, where we labeled the B1, B2, and B3, the machines, where B1 is equal to 30%. We write that as 0.30, B2 is equal to 0.40, 45, and B3 is equal to 0.25. So now we can make 3 separate tree diagrams, where the first half, or the top one is basically going to be the probability of D given B1, which is equal to 0.02, that's 2%, and the probability of D complement given B1 is 0.98, which is 98%. Now we can move on to the next one, which is the probability of D given B2 is equal to 0.03, which is, 3%. And the probability of D complement given B2 is 97%, which is 0.97. Now we can move on to our last one, which is the probability of D given B3, which is equal to 2%. And the probability of D complement given B3, which is 98%. Now we can move on and do a little bit of part A, where part A is asking for the defectiveness. So we can see that the probability of D and B1 is equal to the probability of D given B1 times the probability of B1, which is 0.02 times 0.30, which is equal to 0.006. Made a little mistake right there. I'm sure I'll fix it up. Yep. which is equal to 0.006. Now we can move on to the bottom one, which is the probability of D complement and B1, which is equal to 0.98 times 0.3, which is equal to 0.294. Now we can move on to the second last one, which is the probability of D and B3, which is equal to probability of B3 times probability of D given B3. And there you go. That's our answer right there. Yep. Now I can move on to A, which is the probability of defective. So the probability of D is equal to the probability of D and B1 plus the probability of D and B2 plus the probability of D and D3. All three are defective. Now I can write these as independents, where the probability of D, where we can say probability of D given B1 times the probability of just B1 plus the probability of D given B2 times the probability of B2, machine B2, plus the probability of D given B3 times the probability of B3, which we can fill this out because we have the solutions, which is 0.02 times 0.30 plus 0.03 times 0.45 plus 0.02 times 0.25 is equal to 0.0245. Yep, it's equal to 0.025. There we go. So here we have part B, which is the probability of machine 3, B3 given that is defective D, which is equal to the probability of B3 and D over the probability of D, which is equal to 0.005 over what we got with the last problem, 0.0245, which is equal to 0.204.